What if the greatest discovery in human history is hiding inside a moon smaller than Great Britain? While Earth has just one moon, Saturn has nearly 300. It's the undisputed king of moons in our solar system. But out of all those hundreds of worlds, one stands out above the rest. Enceladus. This moon is so incredibly unique that scientists consider it our absolute best bet for finding alien life. It literally has all the ingredients to kickstart biology. But before we get ahead of ourselves, let's take a closer look at this world. At first glance, it looks completely ordinary, but it's only 310 miles across. You could walk across the whole thing in a couple of days, if walking across solid ice at minus 330 degrees Fahrenheit sounds appealing. But there's one thing about it that isn't ordinary at all. It's covered in fresh ice so reflective, it bounces back almost every photon of sunlight that touches it. One of the brightest surfaces anywhere in the solar system. Scientists eventually confirmed something stranger about this frozen little moon. It isn't just orbiting Saturn, it's helping build one of its rings. Every second, roughly 440 pounds of ice and water leave its surface. Most falls back down as snow, but some of it escapes completely, spreading out into orbit and forming one of Saturn's most famous features, the E-ring. Without Enceladus, that ring wouldn't last. This small moon isn't just part of the system, it's actively shaping it. So what is actually happening beneath all that ice? Where is all that energy coming from? And could the same hidden engine also be capable of supporting life? Let's descend toward the small moon that continues to surprise scientists decades after they first noticed it. To understand why Enceladus became one of the most important worlds in the solar system, we have to go back to 2005. NASA's Cassini spacecraft had just arrived at Saturn after a journey of nearly 7 years. Its mission was to explore Saturn and everything around it. Enceladus wasn't the destination. It was simply a small gravity assist on the way to larger, more interesting targets. Scientists expected little more than another frozen ball of ice. Then something unexpected happened. Cassini's magnetometer, essentially an extremely sensitive compass, detected an unusual disturbance in Saturn's magnetic field around the tiny moon. Bending like it does around something with an atmosphere. A solid frozen world shouldn't have been able to do that. The instrument's lead scientist, Michel Dougherty, argued for a closer flyby. Months later, Cassini's cameras confirmed her suspicion. Given the stakes, who wouldn't have pushed for a closer look? Enormous geysers were erupting through fractures near the South Pole, blasting water and ice hundreds of miles into space. It looked less like a frozen moon and more like a world breathing. Finding the plumes was astonishing. Understanding where they came from was even harder. The first clue was the geysers themselves. Water and ice were blasting out of the tiger stripes at nearly 800 miles an hour, more than 4 times faster than a Formula One car during a typical race. Cassini had never been designed to fly through storms of microscopic ice. Every pass risked damaging the spacecraft. But scientists kept sending it back. Why? Because every flyby revealed another piece of the puzzle. Then came the second clue. Each flyby produced tiny changes in Cassini's speed, almost impossible to notice. Yet Enceladus was pulling on the spacecraft slightly harder than a solid ball of ice should. Something massive was hidden beneath the South Pole. Then came the final clue, the Moon itself. As Enceladus orbited Saturn, it wobbled ever so slightly. Like a raw egg spinning differently from a hard-boiled one, its icy shell wasn't moving as a single solid body. There was only one explanation. A global ocean was separating the ice from the rocky core. So, there's an ocean, but this moon is freezing cold. So where's the heat coming from to keep any of it liquid? The answer wasn't the sun. It was Saturn. Every orbit, Saturn's gravity stretches Enceladus, then squeezes it, then stretches it again. That constant flexing generates heat deep inside the rocky core. Water circulates through the hot rock, reacts with minerals, and rises back toward the surface. The same process that powers hydrothermal vents on Earth's ocean floor. Then, in April 2017, Cassini detected molecular hydrogen inside the plumes. On Earth, that very gas fuels entire ecosystems living around hydrothermal vents without a single ray of sunlight. Water, heat, fuel. One by one, the conditions for life were falling into place. Only one question remained. Did that hidden ocean also contain the ingredients life itself is made of? Every living thing on Earth is built from the same 6 basic ingredients. Think of it like a recipe. Miss even one, and biology simply can't get started. Cassini had already found 5 of those 6 ingredients, just by flying through the plumes. Then, in 2023, scientists went back through the old data and found something odd. A toxic gas called hydrogen cyanide. Toxic to us, but also one of the simplest starting blocks nature uses to build the more complex molecules life runs on. A few months later, they found something even more telling. The same salt-like mineral that's in fertilizer and in your own DNA, dissolved right there in the ocean water. That was the 6th and final ingredient. Every single item on the recipe was already sitting inside this one small moon. So the ocean has everything it needs. But not everyone agrees on what that actually proves. Here's the problem. Nature can create complex chemistry without creating biology. The signals Cassini discovered were a breakthrough, but they were also the beginning of a much bigger question. Where exactly are these molecules coming from? How long have they existed? And what is happening inside that hidden ocean beneath the ice? And the biggest question of all is still hanging in the air. Did Cassini find life on Enceladus? The European Space Agency is already studying Enceladus as one of the most exciting destinations for a future mission to the outer solar system. If approved, that mission could launch in the early 2040s, returning to Saturn with instruments far more advanced than anything Cassini carried. Scientists around the world are also developing new concepts, from spacecraft that could study Saturn's system for years, to missions designed to collect more samples from the plumes and even explore the surface near the South Pole. And honestly, I can't wait when frozen jets erupting from the surface may finally reveal the answer. If you enjoy documentaries that explore the biggest mysteries of the universe, subscribe. There's a lot more left to uncover.